So today we are going to look at how we can prepare a salt by using a neutralisation reaction. And we're going to react together some copper oxide, which is a grey powder, solid, it's a base, and some sulfuric acid. And that reaction is a neutralisation reaction. We will form a salt, copper sulfate and water. Okay, so the first thing we're going to do is we're going to measure 50 centimetres cubed of sulfuric acid using a measuring cylinder. I'm going to put this in a beaker. Then we're going to add our copper oxide to the sulfuric acid. Copper oxide is a base, it's insoluble in water, but because it will react with the acid, if I only add a little amount, we should see adding a small amount if I only add a small amount, the copper oxide reacts with the sulfuric acid and we can't see it anymore. At the moment I've still got sulfuric acid that hasn't reacted with the copper oxide in this beaker, and I don't want that. Sulfuric acid is dangerous, so what I'm going to do is I'm going to add extra copper oxide, more than can react with the sulfuric acid. Adding extra is called adding excess, so more than we need for the reaction. By adding excess copper oxide, we make sure all the sulfuric acid has reacted. And we can tell we've added excess because we're left with black copper oxide in the beaker. It's insoluble, so the copper oxide won't react, hasn't dissolved. We can still see we've got lots of copper oxide in that beaker. To this point, the solution is already neutral. The copper oxide has neutralised all the sulfuric acid. So I've now got a solution that's a mixture of dissolved copper sulfate, water and copper oxide that I don't want. So to get the salt I need to purify this some way. And what I'm going to do is I'm going to filter it. Okay, so filter paper, technique for folding filter paper, fold it in half, fold it in half again. And then one of our outside edges you can open out, and I always like to fold it back on itself like that. Doing that means that it will sit more nicely in the funnel. So I'm going to filter my solution into this conical flask. Doing this will leave the residue of the copper oxide in the filter paper, and then my solution should just be a solution of copper sulfate in water. Leave that to run through. So we've passed our solution through the filter paper to try and separate the copper oxide from the copper sulfate and water. I'm actually not particularly pleased with that. I think there's still some copper oxide in there, making it a slightly dark colour, so I'm going to filter it again. The excess copper oxide that was left in the beaker, copper oxide that I filtered out the first time I filtered it, and this filter paper a little bit dirty, so that was worth doing again, and now I'm left with this incredible blue solution of copper sulfate. So the last thing I need to do to make my salt crystals is to remove the water from this solution. And we can do that just in the same way we would move water from any solution. We can use evaporation. So I'm now going to put my solution in an evaporating dish. And if we leave that 2 or 3 days somewhere warm, the water will all evaporate and we will be left with just the copper sulfate. Copper sulfate is a salt. All salts have crystalline structures, and what it will leave us with is blue crystals, and those blue crystals are copper sulfate. I've got here a great big copper sulfate crystal, and you can see it has got a crystalline structure. And if you imagine table salt, you know when you look at grains of table salt, they look like little cubes. If I broke that up, I could make that look like that. It's part of the way the atoms are arranged in copper sulfate. It's got a lovely order and it gives them this beautiful crystalline structure.